Always great to hear Marshall talk. Never Accolades Associate Church with a platform, so it's a lot of things that, for us to think about. So good morning, I'm Eddie Lungosari. I'm a Chief Research Scientist in Accenture. I'm also a program member of the Congress. It is my pleasure to be able to introduce our next keynote speaker. He's the Senior Managing Director of Accenture Mobility, part of Accenture G Digital. Accenture Mobility is a global practice comprising of thousands of practitioners supporting clients across full spectrum of IoT and mobility needs. He's responsible for advancing Accenture's strategy on mobility and IoT and overall the capabilities that stretch across all of our enterprise mobility and application development, testing, and all the IoT development. In his nearly 30 years of career in Accenture, he has actually led many very complex engagements with many of our large clients from large communication companies, financial services, products, and high technology. So please join me welcoming Mr. Jim Bailey.
Thank you. Thank you, everyone, and delighted to be with you and back here at the IoT Solutions World Congress in Barcelona. It's great to see a packed house this morning. We were one of the founding members of the Solutions World Congress last year and really delighted to see such a successful Congress this year. So congratulations to Richard and Eddie and the other advisory council members and Roger for putting on such a great event. I wanted to talk this morning about the worker. There's been a lot of talk throughout the first day and a half of assets, and in our IoT practice, which is just exploding with our client base, we are seeing a lot of work on assets, to be sure. The promise of vehicles that never break down, trains that always run on time, equipment that runs at optimal efficiency is a tremendous promise. However, in addition to asset management and asset performance, the industrial worker is an important component in achieving the vision of the benefits of IoT. Let's go to the next slide. Let me grab the clicker here real quick. Thank you. So, despite the evolutions of robotics and automation, there are literally millions of industrial workers in the world today and in our client base. And these are people who manufacture items, that configure products, assemble products, service products, both repair and maintenance in the field. And they're a very important part of the equation to the Internet of Things. The key with the connected industrial worker is to ensure they're operating at peak efficiency and effectiveness by getting them the right information and the right capabilities they need to do their jobs. These workers are often highly skilled and highly mobile and have complex tasks that they perform on behalf of their employers and customers. Increasingly, with the proliferation of devices, smartphones, sensors, wearable headsets, there are many options to equip these workers to perform their jobs. To perform their jobs in a couple of different dimensions. Their traditional jobs of accessing information from legacy systems, back office systems, procedure manuals that allow them to perform functions as they've performed for years in a less automated fashion, less assisted fashion. In addition, with the integration of connected assets, providing much richer data sets to these employees, they are able to perform their functions even more effectively, even with more targeted information to perform tasks at hand. We're working with a variety of different companies across different industries. We're working with oil and gas companies to equip workers that service well pumps so that they have the right tools and components before they go out to a job site to service or repair a need. We're working with consumer goods companies so that beverage delivery drivers don't have to stop at a retail shop that does not require replenishment that week. So we can efficiently route workers throughout their day, improving productivity and improving effectiveness in the field. We just completed some recent research. We surveyed approximately 500 manufacturing executives in North America, in Europe, and Asia. And 85% of those executives said just within a few short years that connected workers in their enterprise will be commonplace. So the majority of executives in the industrial sector believe this is inevitable. And over 50% see large productivity improvements coming from enabling connected workers. In fact, Gartner has recently said that over 30% of businesses will achieve competitive advantage through connecting workers and exploiting digital technologies. So quite significant. So what is the connected industrial worker? Quite simply, the connected industrial worker is the worker that has the right information at the right time to do the right job. It's equipping that employee with information both from the traditional business as well as from the assets and things around them to effectively perform the job at that time. So let's take an example. This is a simple repair use case that talks about a field worker that is deployed on a daily basis to service and maintain equipment. In this scenario, it begins with the worker logging on, connecting through their device in a secure way, which authenticates the worker for the location, the type of work performed, whether that worker is an employee or a contractor just for the day. The worker begins by receiving their initial work order, either on their smartphone, a heads-up device, or other form of wearable computing that equips that worker to know their tasks for the day. Those devices interact with sensors in the environment around them as they deploy for the day and conduct their routine activities. Sensors in the assets in the particular plant or operation notify the employee of their location, assist with wayfinding, assist also to ensure that before the employee sets out, they have the right components, tools, and materials to perform that task. They're also equipped with smart procedures so that no longer am I looking up or required to carry manuals or have manuals on site to perform complex tasks. And those can be serious undertakings in a nuclear facility or other complex environments. I can provide that employee with heads-up displays that provide those operating procedures, not only generic operating procedures, which literally may be hundreds of pages of information, but provide specific information and specific smart operating procedures for the model of equipment and the specific asset that the employee is out to service that day. In addition, we can provide that employee with digital assistant capabilities, coaching, if you will, for that employee as they perform that task. I'll show in a moment an example of how we're working with clients to provide these digital assistant capabilities, but they're quite powerful, providing detailed instructions, not just text or checklist instructions, but visual guidance to the employee to perform their task effectively. In addition, the employee can access expert resources via video and voice to connect into the job at hand. So if I am a new employee, a new engineer at a energy facility, and I'm out for the day, I'm relatively inexperienced, I open up a panel within my operation and I see a lot of complexity. I'm just not sure as to which wire to connect, which sensor to disable. In order to perform my job effectively and safely, I can connect through to an experienced engineer in a remote location who can see what I'm seeing, I can point an LED light to a particular screw or a particular switch and ask that expert resource, is that in fact the switch I'm supposed to affect? Very powerful assistant capabilities. Once I complete my job successfully, I can update those smart operating procedures with specific information of how I've performed my job to improve that procedure for all others that perform the same task, and also provide specific information as to that piece of equipment that future repair technicians can access to understand behaviors and patterns and problems that may exist with that particular piece of equipment. So with the promise of connected workers, why don't we see more prevalence? In fact, roughly 1/5 of organizations today say that they've implemented the promise of connected workers in their industrial operations. Fully 85% respond that they view their organizations as digital followers or even laggards in implementing the benefits of digital worker. Well, why is that? The feedback is generally that companies aren't sure where to get started. They may lack confidence in deploying these new technologies to workforces where the technology may seem unfamiliar. So we've identified 4 key areas that we believe are important to get started as organizations determine how they want to prioritize and how they want to implement an industrial worker strategy. The first is to identify the key performance metrics. Always start with the business objectives. What are we trying to achieve? Are we trying to achieve an operating efficiency to reduce costs? Are we trying to improve safety and health of our workers? Are we trying to open up new sources of revenue by enabling workers to provide new forms of service to their customers in the field? The second is understanding the user environment. Because as in technology, we can often identify great solutions and create great ideas that are just not realistic in the field. If I'm working with an oil and gas worker, in what conditions is that worker conducting his job? Is he or she able to use their hands, access devices that require their hands, or do they need a heads-up display? Are they working in dangerous conditions where certain gases may create issues with certain devices and create safety hazards? Are they working in dark environments? Understanding the reality of that user environment is critical as companies begin their industrial worker journey. Next is identifying the information available and the information required to achieve that use case. What information is available in the existing environment from existing systems that we can tap into and feed into devices to enable the worker to do their job? How can we enable data coming off that's already instrumented off of assets in the existing environment? How can we instrument new data and bring that data into the use case to create the value that's envisioned by the particular target? And then finally, bringing it all together, which starts with the workers themselves. Engaging the workers early in the process to make sure that we're creating technology and enabling those workers in a way that's realistic and a way that's comfortable for those workers to adopt in their jobs. Starting small, we're seeing a lot of clients pilot these ideas to drive learnings and drive refinement in their environment before they scale and ultimately deploy throughout their enterprise. So what are the benefits of this? Why do this? And I think I've touched on a few of these, but just to provide you some of the common themes that we're seeing in terms of value proposition. Obviously, improved efficiency by enabling the worker to conduct their work in a shorter period of time, more effectively, with less rework, is critical to the business cases supported by the connected industrial worker. But also providing specific information at the point of need to reduce the time to decision making, to enable that worker to determine what is required, what actions are needed, and to move forward. We're also seeing a heavy focus on safety, improving safety for workers that work in a variety of different environments across the industrial sectors. Reducing non-productive time in routing workers and deploying them to their job site. Reducing mechanical failures by ensuring that the job conducted addresses the issue. Reducing rework and avoiding the need to come back. Enhancing training, improving the overall effectiveness and job experience of employees, as well as security and positive identification to ensure that the right workers in the field are accessing sensitive assets at their point of need. There have been studies as to the overall benefits on the side of the connected worker, and they're very similar to what we've heard over the last day or so for connected assets. The improvement of output has been estimated recently roughly to be in the 8 to 9% range, with reduction in cost for workers in the 7 to 8% range. So when we talk about industrial operations, these are real numbers. They're serious numbers and have a dramatic impact, and have been estimated to have an impact of almost 300 basis points to the bottom line of industrial companies. So as we move forward with the Internet of Things, it's vital that we both focus on the asset performance as well as worker performance, because workers are going to be in the industrial sector for a long time to come. So let's look for a moment at a few case studies where Accenture has worked with our clients over the last year to apply the Internet of Things in a connected worker scenario. The first case study is Airbus, one of the largest aerospace manufacturers in the world. We worked with our client in this sector to deploy heads-up displays where workers that were responsible for assembling components in aircraft, assembling seats in aircraft and placing those seats in aircraft, could do so in a way that's assisted in a virtual display that identifies the exact location of those components in the aircraft itself. And it may sound trivial, but when we think about seat placement, and all of us, most of us probably flew here and fly a lot, but the exact placement of seats to the specification of the airline is a precise science. So by providing a heads-up display to the technician that's assembling the components in the aircraft, we can identify and direct that worker to place the seat to the exact millimeter of the distance required in the aircraft itself. This has reduced the amount of time to place seats in an aircraft by 600%, and has improved quality to 100%, because the component is going to the exact place in the aircraft where it's required, which I guess means that you have the exact amount of legroom on your ride home, which may or may not be a good thing, but it's directed by the airlines, and the workers are able to complete their task in a very efficient way. That project was awarded by Airbus their Innovation of the Year award last year as a way to bring technology and the Internet of Things into a major industrial company. Another client we worked with was KPN, a large telecom provider based in the Netherlands, which, similar to my nuclear example, leveraged, in this case, Google Glass to provide visual instructions, hands-free instructions on checklists, pick lists, work orders, and other instructional information to the telecom worker as they worked in the field on switching equipment and other aspects of the physical plant in the telecom. The productivity improvements for the field worker were estimated to be in the range of 20 to 40%, which is a dramatic impact by applying the Internet of Things to this particular use case. This particular example was awarded one of the GLOMO Awards in Mobile World Congress this past year for the example of the best mobile service in the past year. Another example is Marathon Oil, a very large US oil and gas company, which, different than the previous two examples, had a health and safety focus by equipping their field workers with a series of different gas sensors on vests and other equipment issued to the connected worker, Marathon is now able to monitor the safety environment of their plant operations throughout the world, improving not only the safety and health of the employees, but also matching with location information and mapping information so that Marathon can exactly identify the precise number of employees in an area that may have a hazardous condition and assist them with evacuation in the event of an emergency. And then finally, Rio Tinto. This is another example in the mining industry. Rio is one of the largest mining concerns in the world. And in this example, this was equipping industrial workers, both employee and contract labor, to enable what is referred to in the industry as a turnaround process. Most plants, whether they be in the mining industry or oil and gas or chemical industries, in operating a plant, one of the common business practices is a shutdown of the plant periodically, every 18 or so months, to perform proactive maintenance, because otherwise those plants are running essentially on a 24/7 basis. So in order to conduct a turnaround process to maintain a plant, thousands of workers are brought in for a period of 30 to 40 days to conduct those routine maintenance tasks that build up over a period of time and can only be conducted while the plant is idle. By equipping those workers that come in, Rio is able to understand the effectiveness, the location, as well as the productivity of those workers for a variety of different purposes, for health and safety, for work management and planning, but also cost accounting with their employee labor that they involved in the turnaround process. And they've seen a dramatic shortening of the time requirement to conduct the turnaround operation, which is effectively reducing the number of days that the plant is idle and producing no revenue. I'll close with an example, and this is a brief video of an actual client engagement where we're working with Microsoft, leveraging their HoloLens technology in a way that mixes both virtual and mixed reality. I'll describe it before I show it because the video clip is quite brief, but it's very powerful and very effective in I think, articulating what we're talking about. In this example, it is working with an aerospace company in an assembly and repair use case where we're leveraging the HoloLens with those highly skilled workers to help ensure quality and efficiency as they conduct the assembly and repair operation. As you watch the video, and again, it goes by very quickly, so what you will see is equipping the employee with virtual reality. The scenario is, as a relatively new assembly operator, you've now come in, you've been hired into the enterprise, we've provided you training. This is now a way we can supplement that training, provide those digital assistance capabilities that I referred to earlier, to provide you a virtual reality model of the machine that you're intended to service, that you're intended to repair. In addition, it provides mixed reality capability so that when you actually look at the physical machine, it instructs you for the connection of cabling in the right sequence. It literally points you, even while you're moving your head and changing your field of vision, it will point you to the exact connection point that your task is to take you to next. So very rich, very powerful capabilities, and I'm sure most people are familiar, but just drawing this distinction for a moment between virtual reality and mixed reality. Virtual reality being that virtual image of the machine that I now see in my field of vision. Mixed reality being the blending of that virtual reality and the actual world that I'm looking at. So that while I'm moving my head, while I'm adjusting my field of vision, the HoloLens takes me to the specific part of the actual machine where I need to perform my operation. So let me roll the video, and we'll take a look. So here is the virtual image of the machine. This is a cabling operation that requires specific sequence. You see the mixed reality of that blue circle? That's instructing the worker as they look through the HoloLens to make the actual connection. And we're back to the virtual world where I'm instructing a subsequent task. You can see in the white box above there was some text that includes the detailed instructions and checklist for the employee to conduct their business. So more and more we will see these types of equipped worker, these connected worker scenarios where they're interacting with the assets around them. They're interacting with their traditional enterprise technology to not just conduct their work as they've done in the past, but to do so in much more effective ways that reduce costs, improve revenue, and improve safety for workers. At Accenture, we talk about the future of digital and the future of IoT. And sometimes we talk about the future of robotics and automation and what that means for the creation of superhumans, right, in the future. Will we be overtaken by robotics and superhuman technology capabilities? And lately we've turned that around a bit to say, rather than focus on how do we create superhumans from technology, how do we make humans super from the use of technology? And these examples of the connected industrial worker, as we augment their work environment, we integrate them with data coming from assets around them, I think are a great example of how we can make humans super in the connected industrial worker scenario. Thank you very much.